Hello everyone, we are Group 5 and for our project we have decided to analyze HoneyDue application. HoneyDue is an application dedicated for couples who want to pursue more knowledge about their spending habits to manage their finances. Their mission statement is being a small team of passionate developers on a mission to help couples and families build a brighter future. HoneyDue started in 2016 by Eugene Park, who loves personal finance, and Thien Tran, a CTO engineer. They are two personal finance visionaries who started Wallet IQ. Their mission at the time was to help families and friends develop better financial habits. And after a while, they realized that most couples use spreadsheets. So they assumed this was time-consuming and not very accessible, so they launched HoneyDue. Like already mentioned, HoneyDue is an application for couples to use. What makes them different from other applications is the ability to share data with a joint user, such as a spouse. HoneyDue allows you to track your bills and bank balances, which encourages a financial conversation among couples. We found that this application is perfect for couples that share expenses, because not all of couples do that. There is a website for this app, and that is honeydue.com, but it is rather confusing navigating through it, so we wouldn't recommend it. This app can be accessed through Android, iPhone, and iPad. The requirements to use the applications are fairly simple. All you need to do is download the app, provide your name, your spouse's name, phone number, email address, and bank account. This app supports over 10,000 banks. Next, we will discuss the different models we use for our analysis.
Now let's get the conceptual model for HoneyDue.com. This model we put together re-engineering the current state for HoneyDue.com. Let's start by looking at the main entity types in this model. This includes user, bill reminder, bank, account, and transaction. Notice that bill reminder and transaction have double rectangles, meaning that these are weak entity types because they don't have an identifier attribute with them. All these entity types are connected by the relationship types with the user and account entity types in the center of the diagram. The different relationship types in this diagram are uses, have, joint with, tracks, have, and banks with. The joint with relationship type is a unary relationship type. This is where the two partners are connected together, linking them with their finances. Also, the relationship types uses and have are indicated with the double diamond. This means that they are identifying relationship types. Also notice that all of our relationships are one-to-many relationships. Next, let's look at participation constraints. User and bank are the only two entities that are not dependent on another entity to exist, where bill reminder, transaction, and account are all dependent on another entity. For example, you can have a user without having a bill reminder, but to be able to have a bill reminder, you need to have a user for that bill reminder. Finally, let's look at attributes. Each entity type has multiple attributes coming off of it. 3 of the entity types have identifier attributes. These are user ID for user, for account it is account ID, and for bank it is bank ID.
So after we finished our conceptual design, our group was then able to move on, and together we all created our version of the logical design. But before we even started to kind of figure out what components we needed in the logical design, we had a discussion as a group to make sure that we incorporated 3 really integral parts to our logical design. And that would first be data structure, second, data integrity, and third, data manipulation. So once we kind of had discussions about what all of those incorporated and what we wanted in our model, we then decided what we would have our rows titled as. And so we went back to look at our conceptual design and decided that the row titles we would want would be user, bill reminder, bank, account, and transaction. From there, we decided we had to come up with attributes to actually fill those rows. With user, we went with user ID, email, first name, last name. Bill reminder, we had our user ID, bill name, amount, repeats, notification. Bank, we had only 3, user ID, bank ID, and bank name. Account, we had 4, bank ID, account ID, balance, and type. And finally, transaction, we had 5 different attributes in there: account ID, transaction number, timestamp, amount, and budget type. From there, we kind of decided what would be our identifier attributes for each row and what would be our primary and foreign keys. And immediately we realized that user is going to have a primary key, and that is going to be user ID. There's going to be 2 rows that connect to that primary ID in user. The first would be bill reminder. The foreign key there would be user ID, connect to our primary key, user ID, and user. And then bank would also have a foreign ID of user ID and bank ID, and that would connect again to our user ID. Account would have a foreign key of bank ID and account ID going back up to a primary key in bank of bank ID. And finally, the transaction row would have a foreign keys of account ID and transaction number, which would then go back up and connect to the account ID as a primary key in the account row.
Okay, so we're going to go over the physical model now. Start off with the description. After using the HoneyDue application extensively, we each came to similar conclusions about the data requirements for the app. The fundamental functions of the app focus on user information, bank accounts, and transactional data. The app starts off asking for your email address and name, and then jumps into adding your bank accounts. In discussing the data requirements as a group, it quickly became apparent that the bulk of the data would center around transactions. The app then uses these transactions in aggregate to determine budgets, spending, balances, which are the main functions of the app. The function that sets HoneyDue apart from its competition is the ability to share data with a joint account user. So for instance, if my wife and I share checking and savings accounts, but not credit cards, then I share my checking and savings accounts with my wife, and she would not be able to see my credit card unless I choose to share the information with her. This key benefit makes for an interesting challenge in determining the data design. After modeling the data in conceptual and logical diagrams, we determined it was best to track the joint account user with the user ID as a foreign key back to the same user table. And I'll go over that in just a second as we talk about this model. This allows the relationship to be maintained between the 2 users, and the application tier can then handle the aggregating of the data appropriately. So going into more detail on the physical model, we have our HD user table. HD user because it's HoneyDue, and user's a reserved keyword in Oracle, so you can't just use user as your table name. For HD user, we have your basic user information, such as their email, first name, last name, and then we've got user ID as our primary key. Its data type is varchar 210. It would likely be an integer based on a sequence that would start at 1 and run as many users as you have in the system. Then we also have joint user ID, and this is the interesting part of the table, kind of solving for the joint account users problem that I talked about earlier. The joint user ID foreign key allows to aggregate the data and create that relationship between the joint user and the user ID without causing redundant or extra data that you might not need, or another table to store the same ID information that would be in that HD user table. Similar to the way you would set up a employee table with an employee and manager without recreating all of that same employee's information on a separate table. The bill reminder table is foreign keyed back to HD user on user ID. This keeps track of the bill reminders that you've got, the amount, how often they repeat, and the notification date that you would receive those on. This has a composite primary key made up of user ID and bill name. And then we've got the bank table. The bank table has a composite primary key as well, and the rest of these do actually. So the user ID and the bank user ID are the composite primary key, with the user ID being the foreign key back to HD user. So whenever you're querying and you want to know which user is associated with which bank, you would use that user ID to join on. Then we've got the account table. The account table also has a composite primary key with bank user ID and account ID. Bank user ID is the foreign key back to the bank table. So whenever you're trying to find a user associated with a bank and the account that they're associated with, you would have to join in bank and HD user to get that information. And then finally, we have the transaction table. This is where the bulk of the information would be, and it would be the largest table in this database out of these 5 tables. Transaction table keeps track of all of the transactions associated with the account, bank, and the user. So we've got account ID and transaction ID making up a composite primary key, and the account ID is the foreign key back to the account table. Transaction, we also use timestamp, since generally for transactions you want to be very detailed, and I thought maybe sub-second would be better using timestamp for a transaction rather than date, which only goes down to the second. And then we've got a budget type within the transaction table that allows you to keep track of the type that the transaction would fall into, so you can keep track of your budgets and kind of group everything in your spending. Onto the table creation slide. We've got the 5 different create statements that we use to create the tables. The trickiest part about this is that we had to add unique constraints to the foreign keys to make sure that when we were relating back to those with foreign keys from the next table, that they were unique identifiers. Otherwise, you don't have that foreign key relationship. So for instance, under the bank create table statement, you've got bank user ID, varchar 210, and then a constraint for bank ID unique, making sure that bank user ID is a unique constraint that allows for the account table to have a foreign key back to that on the bank user ID referencing the bank user ID. Onto the query examples first slide. We've got 4 different select statements to kind of show off what we are capable of searching for and aggregating within the database in its current setup. First one on the top left, show user's name and their joint user's name where user ID equals 1. So as you can see, we've only got one table in here, but we're joining onto the same table because we're using that foreign key relation back from joint user ID to user ID to pull the primary user's information along with the joint user's information based on just the primary user ID. In the second query on the top right-hand side, we're showing the user ID, bank name, account type, and balance for a specific user. So as you can see on this one, we have bank, HD, user, and the account tables all joined together. This allows us to use those foreign key relations between each to dig down into the accounts and pull the balances for each user aggregated to the top. In the third query on the bottom left-hand side, we're showing the user ID, names, budget, type, and totals for a specific user for a specific month. This would be a pretty common one that you would use within the app, where you would want to pull the first name, last name of the user, or just pull it by the user ID and get the budget type and then the sum total for a month. So if I'm a user, I want to see how much I've spent on food and drink in October in this example. So if I'm Joe Allen, in the background, the app is running a select query pulling from HD user, bank, account, and transaction, and then summing those up for the entire month of October by the budget type. Then the last select query on the bottom right-hand side, we're pulling the total spending by budget type for a user and their joint account user combined for a month. So this one we're actually combining a primary user and a joint account user, which would be another common feature of the app. We're joining again the HD user table, bank table, account, and transaction, and we're just using where the user ID is equal to 1, so we're just using the primaries to pull everything in, and then we're using a subquery to pull in the joint account user's information at the same time, and using a between statement to get the entire month of October. And this allows us to aggregate again for a user by budget type for an entire month, and it includes everything from the joint account user that the joint account user would want to share with the primary account user. For the last query examples, we want to show the delete statements failing on HD user, bank, and account based on those foreign key relations that we've gone over. So you can see here, you would not be able to delete anything from HD user where the user ID equals 1 on there, or any user ID, based on that integrity constraint. So you've got the child records, foreign key records on tables below. This one would be for user, it would be bank user, For bank user, it would be on account, and on account, it would be on transaction, where we would be violating that foreign key relation, so we would not be able to delete from those tables.
Next, we're going to look at features of the HoneyDue app. Current features and future features that could be supported under the current database. We're going to start with the current features, which is the user's personal information, which is stored and displayed. This is first name, last name, email address, and then you're also able to look at your partner's name and email address. Next, you have easy access to your bank information, the different banks you belong to, bank name. Then to go with that, you can see all the different accounts that you and your partner have at the various banks, and more importantly, the totals in all these accounts, so you know exactly where you stand financially. Then with these accounts, you're able to see each of the transactions made in the different accounts. Lastly, you're able to look at bill reminders and see what bills you have to pay coming up. Bill reminders displays the bill name, a bill description, the date and the time that the bill is due. Now let's look at possible future features that this database could support. The first one is more information on the user. This would be things like phone number, so if your partner needs to get a hold of you, you can just click on the phone number on the app and it will automatically call them. Another one would be more banking attributes, such as maybe the bank's address so you can find it easy, phone number. A third possible feature would be an account total feature. This would be nice and convenient to just look at the total in all your accounts. Also to go with this would be a combination of all transactions. So there's a page on the app where you could look at all the transactions from the credit card, the transactions from the bank, and just see them all in front of you on one page.
HoneyDue is very easy to access if you want to become a user. The ability to share data with a joint user is an advantage for this application. There are a couple of things we did find that we thought needed optimizing though, and that is their website. Their website is not user-friendly, hence it's hard to navigate through it, and their application marketing is not the best. HoneyDue has been around for over a year, and 75% of our team did not know anything about it until we worked on this project. Overall though, from our analysis, we believe HoneyDue is a great tool for couples who want to track each other's spending and create an open conversation about financial goals.